Download this code from codegive.com, link in the description below. The dreaded order of operations error, a comprehensive guide with code examples. The order of operations, often remembered by the acronym PEMDAS, parentheses, exponents, multiplication and division, addition and subtraction, or bodmas, brackets, orders, division and multiplication, addition and subtraction, is a fundamental concept in mathematics and programming. A simple misunderstanding of its rules can lead to significant and unexpected errors in calculations, logic, and program behavior. This tutorial will delve deeply into the common pitfalls and provide practical examples across different programming languages to help you avoid the order of operations error. Why order of operations matters. Computers, like humans, follow specific rules when evaluating mathematical expressions. Without a defined order of operations, the same expression could yield multiple different results, making calculations unreliable and programs unpredictable. Think of it like a sentence in English: the order of the words drastically changes the meaning. Similarly, the order in which operations are performed profoundly impacts the numerical outcome. Understanding PEMDAS/bodmas. Let's break down each component of PEMDAS/bodmas. 1 parentheses / brackets, P/B. Anything inside parentheses or brackets is evaluated first. This allows you to override the default order of operations and force specific calculations to be performed before others. Nested parentheses are evaluated from the innermost set outwards. Example: *2*, 3 plus 4, first, 3 plus 4 equals 7 is calculated, then 2*7 equals 14. Without parentheses, the result would be different. 2 exponents/orders, E/O exponents, powers, and roots are evaluated next. This includes operations like squaring a number, x²2, or calculating the square root x. Example: *2 plus 3²2, first, 3²2 equals 9 is calculated, then 2 plus 9 equals 11. 3 multiplication and division, M/D multiplication and division are performed from left to right. This is a crucial point often overlooked. They have equal precedence. If both exist in an expression, the one that appears first from the left is calculated first. Example: *10/2*3, first, 10/2 equals 5 is calculated, then 5*3 equals 15. *10*2/3, first, 10*2 equals 20 is calculated, then 20/3 equals 6.666, depending on the programming language and data types. For addition and subtraction, addition and subtraction are performed from left to right, similar to multiplication and division. They have equal precedence. Example: *5, 2 plus 1, first, 5, 2 equals 3 is calculated, then 3 plus 1 equals 4. The frequent error: ignoring left to right in M/D and AS. The most common mistake arises when people incorrectly assume that multiplication always comes before division, or that addition always comes before subtraction. This is a misinterpretation of the PEMDAS/bodmas acronym. Remember, M/D and AS are groups, and operations within each group are performed from left to right. Illustrative examples with incorrect assumptions. Let's look at examples of how this misconception can lead to errors. Incorrect assumption: multiplication always before division. Consider the expression 12/3*2. Incorrect calculation: due to wrong assumption 12/3*2 equals 12/6 equals 2. Correct calculation: following left to right rule, 12/3, asterisk 2 equals 4 asterisk 2 equals 8. Asterisk incorrect assumption, addition always before subtraction. Consider the expression, 10, 4 plus 2. Asterisk incorrect calculation, due to wrong assumption 10, 4 plus 2, equals 10 to 6 equals 4. Asterisk correct calculation, following left to right rule, 10 to 4, plus 2 equals 6 plus 2 equals 8. Code examples in different programming languages. Now, let's see how this error can manifest in code and how to avoid it. 1. Python. Output asterisk. Explanation, Python. Asterisk in Python, the interpreter correctly follows the order of operations, pemdas, including the left to right rule within m/d and as. Therefore, you'll get the correct answers even without the extra parentheses in example 1 and 2. However, using parentheses for clarity is highly recommended to avoid confusion, especially for complex expressions. 2. JavaScript. Output asterisk. Explanation, JavaScript. Asterisk like Python, JavaScript adheres to pemdas and the left to right rule within m/d and as. The same recommendations apply, while technically correct, using parentheses improves readability and prevents potential misinterpretations. 3. C/C++. Output asterisk. Explanation, C/C++. Asterisk C and C++ also follow pemdas and the left to right rule. However, integer division is something to be mindful of. If 12 and 3 were floating point numbers, example 12.0 and 3.0, the result of 12/3 would be 4.0. If they are integers, as in this example, the result of integer division 12/3 is 4. The same principle as above applies, using parentheses greatly improves code readability. 4. Java. Output asterisk. Explanation, Java. Asterisk Java's behavior mirrors C and C++ in this regard. It correctly follows pemdas and the left to right rule. Integer division is also present in Java, so be aware of potential truncation if you're working with integers and expect fractional results. Key takeaways and best practices. 1. Memorize and internalize pemdas/bodmas asterisk. This is the foundation. Understand the hierarchy and the left to right rule within m/d and as. 2. Prioritize clarity with parentheses asterisk. Even if the programming language's interpreter understands the correct order, always use parentheses to explicitly define the order of operations, especially in complex expressions. This makes your code easier to read, understand, and maintain. It also eliminates potential ambiguities and reduces the likelihood of introducing errors. 3. Test thoroughly asterisk. Whenever you have mathematical calculations in your code, create test cases to verify that the results are what you expect. This is especially important when dealing with more complicated formulas or logic. 4. Consider data types asterisk. Be aware of how data types, example integers versus floating point numbers, can affect calculations, particularly with division. Integer division can lead to unexpected results if you expect fractional values. 5. Break down complex expressions asterisk. If an expression is very long and intricate, consider breaking it down into smaller, more manageable parts. This improves readability and simplifies debugging. Store intermediate results in variables with descriptive names. 6. Code reviews asterisk. Have another person review your code, especially when dealing with complex calculations. A fresh pair of eyes can often spot potential errors or ambiguities that you might have missed. 7. Use a calculator for verification asterisk. When in doubt, use a scientific calculator to verify your calculations. Many calculators allow you to enter complex expressions and will correctly evaluate them according to the order of operations. Beyond simple arithmetic. The order of operations is not just relevant to simple arithmetic. It applies to any expression involving operators, including Boolean logic in languages like Python, and has lower precedence than OR. A or B and C is equivalent to A or B and C. Using parentheses to clarify is crucial. Bitwise operations bitwise operators, example and, caret, also have precedence rules, which can vary between languages. Refer to the language documentation for details. Custom operators, operator overloading. If you're using a language that allows operator overloading, example C++, you need to be especially careful about defining the precedence and associativity of your custom operators. Conclusion. The order of operations error is a common but preventable problem. By understanding the rules of pemdas/bodmas, paying attention to the left-to-right rule, and prioritizing clarity through the use of parentheses, you can write more robust, reliable, and maintainable code. Remember to test your code thoroughly, and when in doubt, use a calculator to verify your calculations. By following these guidelines, you can avoid the pitfalls of incorrect order of operations and ensure the accuracy of your numerical computations. Good luck and happy coding! Don't make this frequent error, order of operations and operator precedence in programming. One of the most common errors programmers, especially beginners, make involves misunderstanding the order of operations and how operators are evaluated in expressions. This can lead to unexpected results, subtle bugs, and frustrating debugging sessions. In mathematics, we learn pemdas/bodmas, parentheses/brackets, exponents/orders, multiplication/division, addition/subtraction, but programming languages have their own, often slightly different, operator precedence rules. This tutorial will delve into this topic with examples and strategies to avoid these errors in various programming languages, primarily focusing on Python, but also mentioning JavaScript and C++. Why is understanding operator precedence crucial? Imagine you want to calculate the average of two numbers, A and B, and then multiply the result by a constant C. A naive approach might be: why is the output 15.0 and not 5 plus 10, /2 2 equals 15, which happens to be correct by accident due to asterisk and slash having equal precedence, or a more intuitive, 5 plus 10, *2 equals 15. It's because of operator precedence. In most programming languages, division, slash, and multiplication, asterisk, have higher precedence than addition, plus. Therefore, the expression is evaluated as 1b/2, 10/2 equals 5. 5 C, 5 equals 10. 3a plus 10, 5 plus 10 equals 15. Understanding operator precedence tables. The key to avoiding order of operations errors is to understand the operator precedence table for your specific language. These tables define the order in which operators are evaluated. Here's a simplified version of the precedence table for Python, highest to lowest. Operator, S, description associativity. Dash 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 dash. Parentheses left to right. Exponentiation right to left. Plus x, x, x unary plus, minus, bitwise not right to left. Asterisk, slash, slash slash, percent multiplication, division, floor division, modulo left to right. Plus, dash addition, subtraction left to right. Bitwise shift operators left to right. and bitwise and left to right. Caret bitwise x or left to right. Code and 124, / code bitwise or left to right. In, not in, is not, equals, comparison operators non-associative. Not logical, not right to left. And logical and left to right. Or logical or left to right. Colon equals assignment expression, walrus, right to left. Key points from the table asterisk. Asterisk parentheses are king. Asterisk operators within parentheses are always evaluated first. Asterisk exponentiation right associative asterisk 232 is evaluated as 2, 3, 2, which is 2 9 equals 5 12, not 2 3, 2 equals 8 2 equals 64. This is because it's right associative. Asterisk multiplication / division before addition / subtraction asterisk this is the classic point of confusion. Asterisk comparison operators asterisk understanding how comparison operators, equals, interact with other operators is important, especially when using logical operators, and, or, not. The most frequent error, forgetting parentheses. As illustrated in the first example, forgetting to use parentheses to explicitly group operations is the most common mistake. Correcting the average calculation asterisk. To correctly calculate the average of A and B multiplied by C, use parentheses. Now the expression is evaluated as 1. A plus B, 5 plus 10 equals 15. 2 15/2, 15/2 equals 7.5. 3 7.5 asterisk C, 7.5 asterisk 2 equals 15.0. Code examples and scenarios, Python. Here are more code examples highlighting potential pitfalls and how to avoid them. 1. Boolean logic and comparisons asterisk asterisk. Explanation asterisk. Asterisk Python's comparison operators, equals, etc., have higher precedence than logical operators, and, or, not. In the incorrect example, Python evaluates xy first, then yz, and finally combines the Boolean results with AND. Fortunately, in Python the chained comparison is an easier and better way to do it. It is important to know though that most languages don't support chained comparisons, so you have to fall back to the xy and yz syntax. Asterisk when you want to combine conditions with and or, use parentheses to ensure the correct grouping of conditions. The correct example shows that, has underscore license and is underscore insured, will evaluate first and then combined by or with age 18. 2. Bitwise operations asterisk asterisk. Bitwise operations, and, caret, often have lower precedence than arithmetic and comparison operators. Explanation asterisk. Asterisk in the incorrect example, b equals 1 is evaluated first because equals has higher precedence than and. The result of the comparison is then used in the bitwise and operation. Asterisk to perform the bitwise and first, enclose it in parentheses, a and b, equals 1. 3. Exponentiation and unary operators asterisk asterisk. Remember that exponentiation is right associative, and unary operators, plus x, also have specific precedence. Explanation asterisk. Asterisk in the incorrect example, the result is -4, because exponentiation has higher precedence than the unary minus. Thus, 2 is calculated first, resulting in 4, and then the unary minus is applied, resulting in -4. If you intend to square the negative value of x, use parentheses, x, 2. Asterisk in the second example 232 is evaluated as 2, 3 2, not 2. Strategies to avoid operator precedence errors. 1. Use parentheses liberally * even if you think you know the precedence, use parentheses to explicitly group operations. This makes your code more readable and less prone to errors, especially when dealing with complex expressions. Parentheses always win. 2. Consult the language's documentation * refer to the official documentation for the language you are using to find the complete operator precedence table. 3. Break down complex expressions * if you have a long and complex expression, break it down into smaller, more manageable parts. Assign intermediate results to variables. This makes debugging easier and reduces the risk of errors. 4. Test thoroughly * write unit tests to verify that your code behaves as expected, especially when dealing with mathematical or logical calculations. 5. Use linters and code analyzers * many linters and code analyzers can detect potential issues with operator precedence. Configure your linter to warn you about suspicious expressions. Examples in other languages, JavaScript and C++. The core principle of understanding operator precedence applies to all programming languages. Here are brief examples in JavaScript and C++ to illustrate the same concept. JavaScript *. C++ *. Important considerations for C+* *. Integer division * in C++, if you divide two integers, the result will be an integer, the decimal part is truncated. If you need floating point division, you must explicitly cast one or both operands to a floating point type, example double. In the example above, double, a plus b, casts the result of a plus b to a double type, allowing for accurate fractional part calculation during division. Headers * you'll typically need to include stream for input/output operations, like stdcode. Conclusion. Mastering operator precedence is an essential skill for any programmer. By understanding the rules of the language and employing strategies like using parentheses liberally and breaking down complex expressions, you can significantly reduce the risk of order of operations errors and write more reliable and maintainable code. Remember to always consult your language's documentation for the complete operator precedence table and test your code thoroughly to ensure it behaves as expected. Happy coding! Don't fall for this common order of operations pitfall, a deep dive. One of the most frequent, yet easily avoidable, errors in programming and mathematics stems from misunderstanding the order of operations. While most programmers are familiar with the acronym pemdas/bodmas, parentheses/brackets, exponents/orders, multiplication and division, addition and subtraction, the subtle nuances, particularly concerning multiplication/division and addition/subtraction, often lead to unexpected results. This tutorial will explore this common pitfall, illustrating it with code examples in Python and explaining how to avoid it. What is the order of operations, pemdas/bodmas? Pemdas, parentheses, exponents, multiplication and division, addition and subtraction, or bodmas, brackets, orders, division and multiplication, addition and subtraction, are mnemonic devices that help remember the precedence of mathematical operations. It dictates the sequence in which operations are performed within an expression to achieve a consistent and predictable outcome. *p/b, parentheses/brackets * operations inside parentheses or brackets are always performed first. Nested parentheses are evaluated from the innermost to the outermost. *e/o, exponents/orders * exponentiation, raising to a power, and other order-related functions like square roots are evaluated next. *md, multiplication and division * multiplication and division have equal precedence and are performed from left to right. This is a crucial point where errors often occur. Asterisk as, addition and subtraction. Asterisk addition and subtraction also have equal precedence and are performed from left to right. The common pitfall, misunderstanding equal precedence. The most frequent error arises when developers assume that multiplication always takes precedence over division, or that addition always takes precedence over subtraction, regardless of their order in the expression. Remember, multiplication and division have equal precedence, the same is true for addition and subtraction. The order they appear in the expression from left to right determines the order of execution. Illustrative examples. Let's consider some examples where this misunderstanding can lead to incorrect results. Example 1, division and multiplication. Consider the following expression. 10/2*5. Many might incorrectly assume that the multiplication should be performed before the division, leading to the calculation 1/2*5 equals 10. 2/10/10 equals 1. However, this is incorrect. According to the order of operations, division and multiplication have equal precedence, so we evaluate from left to right. 1/10/2 equals 5. 2/5*5 equals 25. The correct answer is 25. Example 2, addition and subtraction. Consider this expression. 10, 4 plus 2. Incorrectly, someone might think addition always goes first. 1 4 plus 2 equals 6. 2 10, 6 equals 4. The right approach follows the left to right rule. 1 10, 4 equals 6. 2 6 plus 2 equals 8. The correct result is 8. Code examples in Python. Let's translate these examples into Python code to demonstrate the effect of the order of operations. Output asterisk. As you can see, failing to adhere to the correct order of operations can lead to dramatically different results. How to avoid order of operations errors. Here are some best practices to avoid falling into this common trap. 1. Use parentheses/brackets asterisk. The most effective way to enforce a specific order of operations is to use parentheses. Parentheses clarify the intended evaluation sequence, making your code more readable and less prone to errors. Even if you think you understand the precedence, parentheses can enhance clarity for others, and your future self. For example, instead of 10/2*5, write 10/2*5, if you truly intend to multiply before dividing, or 10/2*5 if you intend to divide first. 2. Break down complex expressions *large, complex expressions can be difficult to read and debug. Break them down into smaller, more manageable parts. Assign intermediate results to variables to improve readability and simplify the evaluation process. 3. Test thoroughly *always test your code with a variety of inputs, including edge cases and potentially problematic values. This helps identify unexpected behavior caused by order of operations errors. 4. Understand operator precedence *. Be intimately familiar with the order of operations in the programming language you are using. While most languages follow the standard pemdas/bodmas convention, there can be subtle differences or extensions, example operator precedence in bitwise operations or logical operations. 5. Code linters and static analysis *. Many code linters and static analysis tools can detect potential order of operations issues, especially when there's ambiguity. Configure these tools to flag potentially problematic expressions. Real-world implications. While these examples might seem trivial, order of operations errors can have serious consequences in real-world applications. Scientific computing incorrect calculations in scientific simulations can lead to inaccurate results and flawed conclusions. Asterisk financial applications. Asterisk errors in financial calculations can result in incorrect balances, inaccurate reports, and potentially significant financial losses. Asterisk engineering. Asterisk mistakes in engineering calculations can lead to design flaws and potentially dangerous structural failures. Asterisk game development. Asterisk incorrect order of operations can cause unexpected game behavior, glitches, and a poor user experience. Advanced examples. Let's examine more complex examples to further solidify your understanding. Example 3, combining exponents, multiplication, and division. Output asterisk. Example 4, order of operations with Boolean logic, Python specific. While pemdas/bodmas applies to arithmetic operators, Python also has precedence rules for logical operators, and, or, not. It's worth noting them, though they aren't directly related to the initial problem. Output asterisk. In this case, the result is the same, but if x was false the outcome would be different. Example 5, order of operations and data types, implicit type conversion. The order of operations can also be influenced by data types. For instance, consider integer division versus floating point division in Python 2.x, although this is less relevant in Python 3.x, it's important to understand the underlying concept. In Python 2.x. In Python 3.x. In Python 2, if both operands are integers, the result is an integer, truncated towards 0. In Python 3, the slash operator always performs floating point division. The // operator in Python 3 provides integer division. Conclusion. Mastering the order of operations is fundamental to writing correct and reliable code. By understanding pemdas/bodmas, paying close attention to the equal precedence of multiplication/division and addition/subtraction, utilizing parentheses for clarity, and breaking down complex expressions, you can avoid this common programming pitfall and ensure your code produces the intended results. Remember to test your code thoroughly and consider using code linters to help catch potential errors. Always prioritize clarity and readability, even if it means adding extra parentheses, to make your code easier to understand and maintain.